I have a rational expression here. And a rational expression is any algebraic thing that can be written as a fraction. So because I clearly have a numerator and a denominator there, this would be a rational expression. So the task here today is when I look at this, it's got x's and x squareds and all sorts of things all over the place. And I'm wondering if I can simplify it. So when you have a division like this, right, you don't want to leave it as 10 divided by 2. You want to actually do the division if you can. So over here, you just have the sticky issue of how exactly do you divide a quadratic by a linear thing. And the answer for the moment is you can't, unless you can factor the top here to get a common factor that will tidily divide out. So in this particular example, I'm going to try factoring the top. So to factor this trinomial, I need an x in each bracket. And then I need a pair of numbers that add to or multiply to positive 3 and add to negative 4. So if I make my list of things that multiply to 3, there it is. I suppose also negative 1 and negative 3. Exactly one of those pairs will also add to negative 4. 1 and 3 is positive 4. That's not it. Negative 1 and negative 3, there's your match. So this thing factors as x subtract 1 and x subtract 3. Now here's where I can do some division. I have a thing here multiplied by x minus 1 and then divided by x minus 1 immediately afterwards. Now when you do that, the multiplication by this and the division by this undo each other. So they divide out. I'm just going to write that down. It's important that you sort of call it that. These two pieces divide each other out. Not cancel. Don't use the word cancel. They divide each other out. So if you were to do that, this divides this out. You're left with x subtract 3. So this expression here, x squared minus 4x plus 3 over x minus 1, is identical to x minus 3. And if you want to test that, just pick a number. Try x is 1. Try x is 3, maybe. 3 squared is 9 minus 4 times 3 plus 3 over 3 minus 1. I just put the 3 into this. Would give me 9 subtract 12 plus 3 over 3 subtract 1 is 2. 9 and 3 is 12 minus 12 is 0 over 2. I get 0. Now if I put it in the other side, 3 minus 3 is 0. I get exactly the same answer. So you've been able to use factoring to break up the numerator of this and then use a piece of the numerator to divide out the denominator so that you didn't need to write this as a fraction at all. So that's handy. There is a tiny catch if you're going to do that. On this line here, when you divided each other out, you divided by x minus 1. Just fine. This divides this. Except in one particular case. You cannot divide by 0. You can divide by any other number, it's fine. But you cannot allow that to be 0. So if I look at this little expression here, then just to add 1 to both sides, x cannot be 1. So this little phrase here, this expression is equal to that as long as x cannot be 1. So you need that included in your statement because you divided by a variable. Now this one I had up here a minute ago, I didn't need to make that statement for this question because the statement would be 5 cannot equal 0, which is obvious and fundamentally true. But this thing, because it has a variable in it, if x is 1, then x minus 1 is 0, and I would have divided by 0, and that's forbidden. And if you want to sort of check that, I'm going to try putting 1 into this expression. So I get 1 squared minus 4 times 1 plus 3, or 1 minus 1. Gives me 1, subtract 4 plus 3 over 0. 1 plus 3 is 4, minus 4 is 0, divided by 0. On this side, though, if I put in the 1, I get 1 minus 3 is negative 2. So at any value except 0, these things have the same output. But if you, at any point except x equals 1, these two expressions have exactly the same input. But if you put 1 in there, suddenly they spit out something random. Right? There's a mismatch at that one particular place. So whenever you're reducing a radical, you're allowed to factor and you're allowed to use factors to divide each other out, but you must include the statement that x cannot equal whatever at that place where there's a factor was divided out. You have to state this because at that one particular place, weird stuff happens. So I'm going to clear this off and we'll try another example. So I have another trinomial over top of a linear term. So I'm going to try doing some factoring. Factor the top. I need an x and an x. And two numbers that multiply to 8 but add to 6 would be 4 and 2. That's x plus 2, x plus 4. This factor in the bottom, both 3x and 6 are divisible by 3, so I'm going to pull out a factor of 3, leaving x plus 2 behind. And I see I have a factor on top and a factor on bottom that are going to divide each other out. So I end up with x plus 4 divided by 3, as long as x plus 2 is not 0, which means x cannot be negative 2. All right, so we want to test that. If you try 1, try x is 1. The numerator here would be 1 squared plus 6 times 1 plus 8 over 3 times 1 plus 6. That's 1 and 6 is 7, 7 and 8 is 15. 3 times 1 is 3, plus 6 is 9. Both of those divide by 3, so it reduces to 5/3. If I try 1 in this expression, I get 1 plus 4 over 3, which is 5/3. So they have exactly the same output. So this expression is equivalent to that expression, as long as x isn't negative 2. So again, just to underscore why you need to write this, I'm going to try putting negative 2 into this expression, and I'm going to try putting it into this expression. So into the bottom one, negative 2 plus 4 over 3. would be 2/3. So that's a number, right? No questions about what the value of that is. If I put it into the top one, -2 squared plus 6 times -2 plus 8 over 3 times -2 plus 6 gives me 4 minus 12 plus 8 over -6 plus 6, which gives me 0 over 0. Now that's not 2/3. I don't know what that is. If you put a 0 in the top of a fraction, right, like 0 quarters, that's worth nothing. But if you put a 0 in the bottom of a fraction, 4 divided by 0, that's infinity. Right? How many times can you fit nothing into 4? Well, as many times as you like. So this fraction here, this is a conflict, right? It's either worth nothing, or it's worth infinity, or it's worth something in between. I don't know. Curious. You'll talk about this more in the grade 12 class. This is called an indeterminate form. And all you really need to know about it for now is that this indeterminate form was not 2/3. Right? This is not indeterminate. It has an exact value. And this was mysterious. So these two expressions, this one we started with and this one we simplified it to, have the exact same output at every value of x except that one. Because at that one, this thing goes haywire and spits out the indeterminate form. All right, I'm going to clear this off and do a couple more examples. So I've got squares on both the top and the bottom now, so I'm going to have to factor both. Top, that's a classic trinomial, so I need an x and an x. And I need two numbers that multiply to 15 and add to 8. That'll be 3 and 5. And in the bottom, I have an x squared subtract a 9. A 9 is a perfect square. X squared is a perfect square. So that looks like difference of squares factoring to me. So I need an x in both brackets. I need a 3 because 3 times 3 is 9. And one of them has to be positive and one of them has to be negative so that we don't end up with the cross term. We don't end up with any x's, just x squareds and numbers without x's. So I see my two factors here that are able to divide each other out as long as x plus 3 does not equal 0. So x cannot equal -3. So my simplified expression is just x plus 5 over x subtract 3 as long as x is not -3. Okay, I hope you're getting the hang of this. There's just one more example to do, and then we're off to practice problems. And I see a linear term on top, both pieces divide by 4, so there's some common factoring to do there. I see a trinomial on the bottom with a number in front. So there's two choices for the factoring there. Either I'm going to be able to common factor out a constant, the 3, or I'm going to have to use decomposition factoring. So I'm going to check these numbers, 3, 12, 36, all those numbers divide by 3, so I'm just going to pull them out. Squared there, 3 times 4x, 3 times 4x would be 12x, and 3 times -12 would give you -36. On the top, 4 times an x gives you 4x, and 4 multiplied by -2 gives you -8. So that's factored there. I have a simple trinomial inside this bracket here. I'm hoping I can factor it. So So I need an x in front, and I need two numbers that multiply to negative 12 and add to 4. I think that's negative 6, no, positive 6 and negative 2. So when I do that, I can see the x minus 2 and this x minus 2 will divide each other out as long as x minus 2 is not 0, because that's where the indeterminate form would show up. So x cannot be 2. So finish it off here. The only thing left on top is a 4. The only thing left in the bottom is 3x plus 6, as long as x cannot be 2. All right. So if you're given a complicated thing like that, it's always a good idea to see if it simplifies. And if you are able to do any factoring, then you can do some dividing out. As long as you acknowledge that at the place you divided out, you have eliminated the indeterminate form at that particular place. So you just have to acknowledge that this number is forbidden in your new expression.